All right, so today here on campus, students were given some enrichment problems to work on. And so we took time here in class to work on these. So if you're doing this as an online student, what I recommend doing is pausing the recording and trying these problems on your own. And then when you're ready to see the answers, see me work them out, then you can resume recording and see the answer key. So here, problems 1 through 4, pause it, try it for yourself, and then go over it when you're ready. Here are problems 5 through 9. Again, pause it, try it for yourself, and then hit resume when you're ready. And then here are 10 through 12. And the last ones are right here. So again, hit pause, try these problems for yourself, and then when you're ready to see the answers, you can resume the recording and see what you got right and what you still need to work on. All right, so we are going to now go over all of these, and hopefully this will answer any questions about this stuff that you might still find confusing. So it says, draw Lewis structures for each of these, and if resonance exists, give all possible resonance structures. So what's the formula for the carbonate ion? What is that? CO3 with what charge? 2 minus, right. So carbon has how many valence electrons? 4, and each oxygen has how many? 6, and there are 3. And then what do we do with this -2 charge? What do we do with it? We have to add 2, right? Why are we adding? Why do we add for a negative charge? What does a negative charge mean? That you've gained extra electrons, right? So you have to have those added in there, right? Make sure you understand that when it is a -2 or a -3 or whatever that's negative, you're adding electrons, right? Not taking them away. When would you be taking them away? If it's a positive, right? If it's a cation. So we've got 24 valence electrons to work with. So who is the central atom? How do you choose that? You need what information?
Which one's the least?
The least electronegative atom is in the center, right? Because that is the one who's best at sharing. So who is in the center, carbon or oxygen? Carbon, right? So I'm actually going to give myself a little bit more space here. All right. So carbon goes in the middle. So C, and then we're going to connect with single bonds, O, O, O. And I've got 24 to work with, so I can go ahead and give everybody an octet. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Right, so that takes care of all 24 electrons right there. So when you run out of electrons, you need to evaluate your Lewis structure and ask yourself, is there anything that I need to rearrange now that I'm out of electrons? Does everybody have an octet? No. Who is missing an octet? The carbon is, and how can I give carbon an octet? Form a double bond. So arbitrarily pick one of them, put that pair right here, and now it's a polyatomic ion, so don't forget your brackets and your charge. Is that the only possibility though? No, how many other Lewis structures could I have? 2 other ones, right? So we use this double-headed arrow to indicate resonance. So our other Lewis structure would have the double bond on the top. And don't forget the brackets. And then our other resonance structure would have the double bond on this side. So, single bond. Oops, that's a single bond here too. Do we agree on this one? Any questions on how we do the Lewis structure for carbonate? All right. We good if I erase? This video will be up later on today if you need to check anything out. And I will make a photocopy. I wrote my answers here, so I'll scan this and post it on the course website too. So if you want to look at the PDF version of it, I'll post it up there this afternoon as well. All right, let's do the Lewis structure for carbon monoxide. Give myself some more space here. Okay, carbon monoxide. Carbon has how many valence electrons? 4, right? And how many does oxygen have? 6, so I've got a total of 10 to deal with. Now, do we have to worry about central atom here? Not really, right? Because it's just 2 atoms, right? So you don't really need to worry about who's in the middle because there's not really a middle. So carbon, oxygen, so that's 2, 4, 6, 8, 10. All right, there's all 10. We're out. So what do I need to do here? We need to form a triple bond, right? So put a pair right here, triple bond, pair right here, triple bond. 2, 4, 6, 8. Excuse me, 2, 4, 6, 8. 2, 4, 6, 8. Everybody's got an octet. We're good to go. Any questions on carbon monoxide's Lewis structure? Right. Let's do nitrogen gas, N2. So nitrogen, each nitrogen has how many? 5, right? And there are 2 of them, so I get 10. So again, do we need to worry about central atom? No, because it's just 2 atoms, right? So N, single bond, N, 2, 4, 6, 8, 10. All right, what happens here to give octets? You're going to form what? Triple bonds as well, right? And that's our final answer. By the way, if I asked you on a test, what's the bond order? You might see this on the homework too. What's the bond order? The bond order is just, is it single bond, double bond, or triple bond, right? So what would the bond order here be? It'd be triple. We call that, we just say 3. The bond order there would be 3. Okay? Also, you might see questions on the homework about number of unpaired or number of non-bonding electrons. These electrons right here are non-bonding electrons. Sometimes they're also known as paired electrons. Okay? So if you see questions like that on the homework, those are just vocab words. Right, so if I asked you, what's the bond order in N2? You would say bond order is 3. If I said, how many pairs of non-bonding electrons are there? 1 pair, 2 pairs. Right? There are 2 pairs that are not bonding. These electrons are not in a bond. These electrons aren't in a bond. They're just hanging out. Okay? So if you see questions like that on the homework, that's what it's referring to. All right, let's look at carbon tetrachloride. Carbon tetrachloride, CCl4. So each carbon has how many electrons to deal with? 4. And each chlorine has how many? 7. And there are 4 of them, right? Do we need to worry about adding or subtracting any electrons? No, right? Because this isn't a charged molecule. So we've got 32 to work with. Central atom. Who's in the middle? Carbon, right? Carbon's way less electronegative than chlorine. So 1 in the middle, and then chlorine, 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 chlorine. When you give everybody an octet, that takes care of all 32. So then you just need to check, does everybody have an octet? Is everybody satisfied? And the answer is yes. Do you need to do any rearranging? Do we need to put any brackets? No. So if I said, what's the bond order here? What would it be? 1, right? Because that's a single bond. Any questions related to the Lewis structure for CCl4? Okay. Let's look at boron trifluoride. Spell checker doesn't like that. Add to dictionary. All right, BF3. So boron has how many valence electrons? 3. And each fluorine has how many? 7. So that's 24 valence electrons. Who goes in the middle? Boron, right? Is fluorine ever going to be in the middle? Not if you can avoid it, right? Fluorine's very electronegative. It's not going to be your central atom. So B, F, 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 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, oops, 22, 24. There we go. Now, do we need to form any double bonds here? This is a trick question. If this were, say, carbon as the central atom, which it wouldn't be, but let's just pretend it is, would we need to form double bonds? Yes. Why do we not need to form double bonds here for a boron central atom? It only needs 6, right? Boron is an exception to the octet rule. Yeah, boron needs 6 valence electrons.
Boron needs 4. Beryllium needs 6.
On your handout? Yeah, that's backwards.
Okay.
6 valence electrons is all boron needs. So C is 2, 4, 6.
And then beryllium needs 4.
Yep, I just wrote that backwards. We'll do a beryllium one here in just a second. Any questions on the Lewis structure for BF3? Let's do oxygen gas. Okay, oxygen, each oxygen has how many valence electrons? 6, and we've got 2 of them, so we've got 12. So no central atom because it's just 2 atoms, right? So 2, 4, 6, 8, 10, 12. Am I finished? No. What's wrong? The oxygen on the right, does it have an octet? So what do? Form a double bond. And I'm finished. Questions on O2. If I asked you what the bond order is, what would the bond order be? 2. If I said, how many pairs of non-bonding electrons do you have? There'd be 4 pairs, right? Non-bonding pair number 1, pair number 2, pair number 3, and pair number 4. So all these guys are non-bonding. They're just hanging out. The bond order here would be 2. Questions on O2? Questions on O2? All right, let's look at sulfur dioxide, SO2. All right, sulfur is how many valence electrons? Well, sulfur and oxygen are in the same group, right? Sulfur is directly under oxygen. So how many do each one of these have? 6, right? They've got 18 to work with. Who goes in the middle? Sulfur, right? Because it is less electronegative. Remember, if I ask you why an atom is in the middle, don't tell me because it's symmetric. Don't tell me because it needs to look balanced or anything like that, right? The reason is because sulfur is less electronegative. So S, and then O, and then O. So 2, 4, 6, 8, 10, 12, 14, 16. Where do the leftovers go? On the central atom, so right here. So I'm out of electrons, so now I just check, does everybody have an octet? No. How can I achieve an octet? How many double bonds would I need to make? Just 1. right? I'd only need to make one, right? 2, 4, 6, 8. Is there another resonance structure that would achieve that same end? Yes. Now, I will warn you, when you get to general chemistry, we're going to start talking about something called formal charge. And when we study molecules involving double bonds in Gen Chem, we'll learn that we can form double bonds to solve a formal charge problem. And so we might come up with additional resonance structures where we can play around with double bonds and that sort of thing. But here in Intro Chem, we're not going to worry about that. Formal charge is not something you're responsible for. So if you see your textbook talk about formal charge, I don't think it does. But if you're reading internet resources or whatever, formal charge is something we deal with in general chem, but you won't have to worry about that in Intro Chem. Any questions on SO2? Let's look at beryllium dichloride. We can do hypochlorite too, because those are small molecules. Okay, beryllium dichloride. How many valence electrons does beryllium have? Beryllium has how many? 2, and then each chlorine has 7. So I've got 16. Who's the central atom? Beryllium. So Be, and then Cl, Cl, 2, 4, 6, 8, 10, 12, 14, 16. And that's it. That's all I have to do. Why? Why do I not need double bonds? Right. Beryllium is an exception. Only needs 4. It has 4, so it is satisfied. Questions on number 8? All right, let's look at number 9. Each chlorine has how many? 7, and each oxygen has
6.
And what do I do with that negative charge? Add 1, right? So that gives me a total of 14. No central atom because this is just a 2-atom molecule. So Cl, and then O, 2, 4, 6, 8, 10, 12, 14. Am I done? What am I missing here? This is a polyatomic ion, so what do I need? You need brackets with the charge, right? To show that the entire molecule carries a negative charge.
We don't put brackets on all of them,
Just polyatomic ions, yes. So you wouldn't need a brackets around this one because there's no charge.
Okay.
You only need the brackets to show that the entire molecule carries that negative charge. Any questions on 8 or 9? Feeling good about these? All right. Let's look at number 10, nitrosyl chloride again. Spell check doesn't like that. Good. Okay. Nitrogen has how many? Nitrogen has 5. Oxygen has 6, and chlorine has 7. So how many am I working with? What? 8. So do we need to have a central atom conversation here? We do. This is a 3-atom molecule, right? Who's the central atom? Why is nitrogen the central atom? It's the least electronegative, right? This one is least electronegative. So it goes in the center. And then what? Form single bonds. Does it matter if O is on the left or O is on the right? No. So you can put those in any order you want. O and Cl. All right, so 2, 4, 6, 8, 10, 12, 14, 16, 18. Do we agree? That uses up all 18 electrons. Now I need to evaluate my Lewis structure, right? Make sure everybody's satisfied in terms of the octet rule. Is everybody satisfied here? What's wrong? Nitrogen needs an octet, and so how can I do that? Form a double bond. Now this is a rule that I haven't explicitly told you yet. This is your only answer. And the reason for that is because double bonds to halogens, right, so that's your group 7, fluorine, chlorine, bromine, iodine, okay, are not common in terms of the molecules you're going to be dealing with. Okay, when you start taking transition metal chemistry and you start dealing with the D block and you get into some more complicated Lewis structures, you can worry about your double bonds to halogens. But here in intro chem, you're not going to deal with double bonding to halogens. So this is our only Lewis structure. That's not a rule that I had explicitly told you yet. How do we feel about this one? Yes? Okay. Any questions on this one? All right, sulfur dichloride. We can probably fit formaldehyde on here too. So you've got 6 and 7. So we've got 20. Who's in the middle? S, sulfur. Cl, Cl, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Is there any arranging that needs to take place here to give octets, or are we good to go? We're done. That's all we have to worry about here, right? Everybody's already got an octet, so there's nothing fancy to do. I think we've got enough room to do formaldehyde. If I start writing right here, can you guys in the back see okay over the... Okay, so carbon has how many valence electrons? 4, and then hydrogen has 1. And then oxygen has 6. So how many do I have? 12. Okay, who's the central atom? Carbon, right? Carbon is the only one that makes sense because hydrogen can never be the central atom. Oxygen is too electronegative to be the central atom unless you have no choice. So carbon goes in the middle. C, and then O, and then H. H, right? If you had put the O up top and the H right here, that's the same molecule, just rotated, right? So if you had drawn it like this, you're just taking the same molecule and rotating it, right? So in either scenario, 2, 4, 6, do the hydrogens need octets? Nope. So 2, 4, 6, where do the remaining 6 go? On oxygen, right? You always fill your octets of your outer atoms first. 8, 10, 12. Or if you drew it like this, 8, 10, 12. And now you just look at your answer and say, okay, does everybody have an octet? No. What do I do to give octet? Form a double bond. So there's your answer if you drew it that way. There's your answer if you drew it that way. Questions on formaldehyde? last two we have are exceptions to the octet rule, where you have an odd number of electrons. So if you've noticed by now, the majority of the Lewis structures we come across have even numbers of electrons, right? Because electrons are coming in pairs. But there are times where you have an odd number. My rule of advice, or my piece of advice I should say, is that if you come up with an odd number, go back and double check your adding and make sure you didn't just add something incorrectly, because odd numbers of electrons are unstable and they're relatively rare, right? They're not things that you're just going to have for long periods of time. They're very unstable, okay? A lone electron is called a free radical. So these will react very quickly to get that second electron so that they can be together in a pair. But sometimes you have an odd number of electrons and then you're like, well, I'm stuck, right? Because you're probably going to be in a situation where somebody doesn't have an octet if you have an odd number of electrons. So let's do nitrogen dioxide. Nitrogen has how many valence electrons? 5, and then 6 times 2 gives me 12. So that's 17. Oops. Equals 17. 17 is an odd number. There's nothing I can do to fix that. Right? That's just how it is. Right? So we have to figure out what can I do to make this situation the best that I can make it. Right? Somebody's going to be unhappy. Who's the central atom, nitrogen or oxygen? Nitrogen. So single bond, 2, 4, 6, 8, 10, 12, 14, 16. Then what? You just draw that one by itself. It's just a lonely little dot. It's just a sad, lonely little dot. Let's make sure. 2, 4, 6, 8, 10, 12, 14, 16. Oops, I put too many. There we go. 2, 4, 6, 8, 10, 12, 14, 16, 17. There we go. Looking at that going, there's too many electrons. Okay, now we can do our best to make an octet as much as we can, but the fact of the matter is 2, 4, 5. So let's make a double bond here. Right, that makes it better. 2, 4, 6, 7. Or maybe you put 2 double bonds here. 2, 4, 6, 8, 9, right? It's not going to be an ideal situation, no matter how you spin it. So if you made 2 double bonds, that would have worked. If you just made 1 double bond, I would have accepted that as well, because there's no good situation here. And when you get to general chemistry, we'll learn how to differentiate between differing resonance structures to pick the one that's best. But right now in intro chem, we're just going to come up with as many options as we can, and then next time when you take general chem, we'll figure out which one's the best. But for now, we're just going to come up with as many options as possible. Either way, it's not ideal, right? And this is going to react quickly to get rid of that lone electron. For nitrogen monoxide, you have an odd number as well, right? Because this is 5 and this is 6, so you have 11. So there's no central atom per se because there's only 2 atoms in this molecule. So NO, 2, 4, 6, 8, 10, 11. Right? So you could make a double bond, 2, 4, 6, 7. Maybe you could come up with an option where you had, what other options did you come up with? Did anyone come up with a permutation where the lone electron's on nitrogen?
Yeah.
That one would work. What other options did you come up with? Did anyone try maybe a triple bond? Anyone try a triple bond? Like I said, next semester, if you take general chem, we'll play around with our formal charges and figure out which one's the best. But now in intro chem, we're just coming up with as many options as we can. And then in general chem, we'll use formal charge to distinguish which one's the best. So if those are the only 2 that you came up with, do we understand why these two are just inherently gonna be non-ideal, right? Because if you ever come up with an odd number, first thing to do is go back and just check your math and make sure you didn't forget to add an electron. So for instance, if this was nitrite, NO2 minus, well, that'd have 18, right? You wouldn't have this problem because there is an ion that exists that's called NO2 minus. And so that one is 18 electrons. And hey, you don't have this problem because of that negative, you add an electron, right? So if you ever come up with an odd, first thing you need to do is go back and check your arithmetic. Just make sure you didn't forget it, but this was not nitrite, this was nitrogen dioxide. So there is a difference between these two, okay? And they will have different Lewis structures. But first thing to do before you start drawing a free radical is check your math. Always make sure you check your math first. If you forget to add or subtract electrons, that's the number one reason that you come up with an odd number. But if you do come up with one, and your math still comes out to be odd, then you do your best to give everybody an octet under the non-ideal circumstances. How do we feel about these ones, where they are exceptions to the octet rule because they have less than an octet, and you're forced to have less than an octet? All right, I'll stop the recording.